Hey there, fellow science enthusiasts! Welcome back to another exciting episode of AtlasMap, where we dive into the wonders and curiosities of our universe. Today, we're taking a trip down a very unusual path, one that leads us to a world where the Earth is, well, flat. Yes, you heard that right. We're going to explore the fascinating and bizarre concept of a flat Earth. Now, we know our planet is a sphere, but let's have a little fun and imagine what life would be like if it were as flat as a pancake. Imagine holding a globe in your hands and then squishing it down until it's completely flat. What kind of changes would we see in our daily lives? Just picture it. No more rolling hills, no more curved horizons, just an endless plain stretching out before us. The landscapes would be drastically different. Instead of mountains and valleys, we'd have vast, flat expanses as far as the eye can see. It's a mind-boggling concept, isn't it? Think about how our perception of distance and travel would change. Would we still have oceans and rivers? Or would everything be spread out in a completely new way? Navigation would be a whole new ballgame. Without the curvature of the Earth, our maps and GPS systems would need a complete overhaul. Imagine the challenges of finding your way in a world where everything is flat. So, buckle up as we explore the strange and wonderful, and scientifically impossible, world of a flat Earth. We'll delve into the physics, the geography, and the sheer weirdness of it all. And what about the night sky? How would our view of the stars and planets change? Would constellations look different? The possibilities are endless and endlessly fascinating. Before we dive in, make sure you hit that like button and subscribe to AtlasMap for more awesome science adventures. Your support helps us bring you more fun and thought-provoking content. Let's get started. First things first, let's talk about gravity. Gravity is one of the fundamental forces of nature, and it plays a crucial role in our everyday lives. It's the reason why we don't float off into space and why objects fall when we drop them. You see, gravity is this incredible force that pulls everything towards the center of a massive object like our Earth. This force is what keeps our feet firmly planted on the ground and ensures that everything from apples to raindrops falls downwards. That's why we stick to the ground and why things fall down instead of up. Without gravity, life as we know it would be impossible. Imagine trying to pour a glass of water or even just walk around without this invisible force keeping us grounded. But on a flat Earth, gravity would act a bit differently. The concept of gravity on a flat Earth is quite intriguing and leads to some fascinating, albeit hypothetical scenarios. Instead of pulling everything towards the center of the disk, it would pull everything towards the center of the flat surface. This would create a very different experience of gravity compared to what we are used to on our spherical Earth. This means the further you moved away from the center, the more horizontal the gravitational pull would be. This would result in a strange sensation as you move towards the edges of the flat Earth. Imagine walking to the edge of this flat Earth. As you got closer to the edge, the gravitational pull would feel more and more like you were walking uphill, even though the ground beneath you would still appear flat. You'd feel like you're walking uphill, even though the ground would appear flat. This would be a very disorienting experience, making everyday activities much more challenging. It would be one tiring commute, wouldn't it? Just imagine the effort it would take to move around in such a world. The simple act of walking could become a strenuous task, and our entire way of life would be drastically different. Gravity, as we know it, truly shapes our world in more ways than we often realize. Now imagine the weather on a flat Earth. Talk about unpredictable. Without the Earth's rotation and spherical shape, weather patterns as we know them would be completely different. For starters, the Coriolis effect, which causes hurricanes to spin, wouldn't exist. Winds would blow in straight lines from areas of high pressure to low pressure, potentially creating some seriously intense storms. And what about the sun? On a flat Earth, the sun would likely be much smaller and closer, moving in circles above the disk. This would create some very strange day and night cycles, with sunlight hitting different parts of the flat Earth at drastically different angles. Think about the landscapes we know and love. Towering mountains, deep oceans, vast deserts. On a flat Earth, these features would be incredibly different if they existed at all. Mountains, for instance, might form strange, plateau-like structures due to the unusual gravitational pull. Oceans, if they could even exist in this scenario, might pool in the center of the disk, leaving the edges dry and barren. And imagine trying to sail around this flat Earth. Without the curvature of the Earth, you'd eventually just reach the edge. What lies beyond? Well, that's a question for another time. Section 5. Navigating a disc-shaped world. Speaking of navigation, finding your way around a flat Earth would be a whole new ballgame. Forget about compasses, GPS, or even the trusty North Star. On a flat Earth, north would always be towards the center of the disk, while south would be in every direction towards the edge. East and west would depend on your position relative to the center. Talk about confusing. Maps would also require a serious redesign. Forget about globes. We'd be looking at flat maps, but even those would be tricky to create accurately without the familiar latitude and longitude lines we use to navigate our spherical Earth. Section 6. Space travel on a stationary disk. Now let's blast off into the fascinating realm of space travel. Imagine the thrill of leaving our planet behind and venturing into the vast unknown. The excitement of space exploration has always captured our imaginations. But what if the Earth were flat and stationary? Space travel would be a very different experience indeed. The very foundation of our understanding of space and physics would be turned on its head. For one, we wouldn't have to worry about escaping Earth's gravitational pull in the same way. Instead of being pulled towards a central point in a spherical Earth, gravity would pull us towards the center of the disk. This would fundamentally change the way rockets are designed and launched. But here's the catch. Orbiting a flat Earth would be impossible. Satellites, which rely on the Earth's curvature to stay in orbit, would simply fall back down to the surface. The concept of orbiting relies on the balance between gravitational pull and the inertia of the satellite's motion. Without a spherical Earth, this balance would be disrupted, causing satellites to plummet back to the ground. This would have a profound impact on our daily lives and the technology we rely on. This means no more GPS, satellite TV, or even space exploration as we know it. Our modern world is heavily dependent on satellites for communication, navigation, and scientific research. The loss of these technologies would set us back decades. Imagine looking up at the night sky and not seeing any satellites zipping by. The sky would appear empty, devoid of the tiny moving dots that represent our technological achievements. It would be a very different and much less technologically advanced world. We would have to revert to older methods of navigation, like using physical maps and compasses. The convenience and efficiency of modern technology would be lost and our progress in space exploration would come to a halt. Section 7. Life on the Edge, the Great Beyond. One of the most intriguing questions about a flat Earth is, what happens when you reach the edge? Some theories suggest a giant ice wall surrounds the disk, preventing everything from falling off. Others propose an infinite plane extending forever in all directions. But let's be real, the laws of physics wouldn't allow for a flat Earth with an edge. Gravity would still be pulling everything towards the center, meaning the edges of this hypothetical disk would be incredibly unstable. So, while the idea of reaching the edge of a flat Earth is a fun thought experiment, it's important to remember that it's just that, an experiment. Section 8. Flat Earth Myths Debunked. Now, you might have heard some arguments supporting the flat Earth theory, but don't be fooled. These claims have been debunked time and time again by scientific evidence. For example, some people claim that the Earth looks flat from airplanes. However, this is just an illusion due to the vast scale of our planet. If you were to fly high enough, you'd definitely notice the Earth's curvature. Another common claim is that there's no evidence of the Earth's rotation. However, we can observe the Coriolis effect, which is a direct result of Earth's rotation, in the way hurricanes spin and objects are deflected in flight. Section 9. The Shape of Science. Why a sphere makes sense. So why are we so certain that the Earth is a sphere? Well, the evidence is all around us. From the way ships disappear hull first over the horizon to the fact that we have different time zones, everything points to a spherical Earth. Even ancient civilizations, through careful observation of the stars and the way shadows are cast, concluded that our planet must be round. And with modern technology, we have even more evidence, like satellite imagery, that confirms the Earth's spherical shape. Science is all about evidence and observation, and all the evidence points to a round Earth. Section 10. Looking up at the round reality. While it's fun to entertain the idea of a flat Earth, it's crucial to remember that our understanding of the universe is based on centuries of scientific discoveries and observations. The Earth is not flat, it's a sphere, and that's a fact. Understanding the true shape of our planet helps us appreciate the wonders of gravity, weather patterns, space travel, and so much more. It allows us to explore our world, navigate the vast oceans, and even send rockets into space. So the next time you gaze at the horizon or look up at the stars, remember that you're standing on a giant spinning sphere, hurtling through space. Section 11. Keep exploring the world, round or otherwise. Even though we've debunked the flat Earth myth, it's essential to keep that spirit of curiosity and wonder alive. Questioning, exploring, and seeking answers are at the heart of scientific discovery. So keep asking questions, keep searching for answers, and never stop exploring the world around you. Whether you're gazing at the stars, experimenting in your backyard, or simply pondering the mysteries of the universe, keep that thirst for knowledge alive. The world is full of wonder, and there's always something new to learn, even if it confirms what we already know. And hey, if you enjoyed this journey into the hypothetical world of a flat Earth, make sure you hit that like button and subscribe to AtlasMap for more mind-blowing science adventures. We're passionate about exploring the universe, from the smallest atom to the largest galaxy, and we love sharing our discoveries with you. So join our community of fellow science enthusiasts and let's keep the adventure going. Together we'll keep exploring, keep learning, and keep asking those big, important questions about the world around us.